Hello everyone, welcome to my channel. In this video, we are going to cover the problems based on the joint distribution. So if you are not confident in the basic concepts of the joint distribution, so I suggest you to first watch the videos based on the joint distribution. I'll put the link in the description box on the videos related to the joint distribution. Please go and watch these videos first. Only then you will be able to understand the problems based on this joint distributions. Now, let's start with the first question. So the first question, it is the two-dimensional random variable xy has the joint density where the function it is given by 8xy, where x is greater than 0, x is less than y, and y is less than 1. So this function is defined in this region, and this function it is 0 otherwise. So since here x and y both are continuous random variable because both are taking values within an interval. So that means it is the case of a continuous random variable. So whenever you have the case of a continuous random variable, always sketch the region where the function is defined. So here the function is defined in this region. So always sketch the region first. So this will be your first step, that sketch the region where the function is defined. So the first is, since the region is 0 is less than x is less than y is less than 1. So sketch the region here. So forget about this less than sign, less than sign. Simply take it as the first one is 0 is equals to x, then x is equals to y, and then y is equals to 1. So plot these three lines first. So suppose this is our y-axis and this is the x-axis. So what is x is equals to 0 line? X is equals to 0 line. If you look at this, that means the first one is 0 is equals to x. So x is equals to 0, it is this line. Then we have x is equals to y, it is this line. And then we have y is equals to 1, y is equals to, if this is 1 on the y scale, so this is y is equals to 1 line. So this is y is equals to 1, this is x is equals to y, and this is x is equals to 0 line. And the corner points are 0, 0. This is 1, 1 because here y is 1, and on the x is equals to y line, x is equals to y as well. So x is equals to 1, and this point is 0, comma 1. So this is the region where the function is defined. So how we find out? Here we have 0 is less than x. That means x is greater than 0. So x is greater than 0. That means this region. Then we have y is less than 1. Y is less than 1. That means we have this region. And x is less than y. So x is less than y. How you are going to find out? Here we have either this region, the area which is above this line x is equals to y, or it is below this line x is equals to y. So simply pick a point from any of these two regions. Suppose I am taking this point. Okay, so this point is 0, comma 1 where x is 0, y is 1, and just substitute it here whether it is satisfying this equation x is less than y. Yes, 0 is less than 1. So what is the region? The region is above this line, that is x is equals to y. So this is the common region where this function is defined, that is 0 is less than x is less than y is less than 1. So where we need to integrate the function, so this is the region. That means this is the region. Okay, so this is the shaded portion. Now, next, the question is, this is the region we have already plotted, that where the function is defined. So the first is, instead of doing this first part, first we will do this second part, that is find the marginal densities of x and y. We'll do this first part later. So find the marginal densities of x and y. So for the marginal densities, we know that for the marginal density of x, that is fx of x, since it is a continuous case and we are finding out the marginal densities, that is the individual density for the random variable x. Since it is a case of a continuous random variable, so we'll use integration, and whenever we have to find out the marginal density of x, then we'll integrate over y values, and the function, that is fxy, integrate with respect to y. So now what is the y value? So this is equals to, since we have to integrate over y, so now the important point is whenever you have to integrate with respect to y, so always move from left to right. So left to right in case of x, and whenever you have to integrate with respect to y, always move from bottom to top. So that means this is bottom to top for y, and from left to right it is for x. So for this function, for y, values will move from bottom to top. So bottom to top, here I am again plotting this region. So basically the region is, this is something like, the region it is, okay, so the region is, that is, this is y is equals to x line. So this is y is equals to x line. This is x is equals to 0 line. That is, this is x is equals to 0. And this is y is equals to 1 line. So that means this line is y is equals to 1. The points are 1 comma 1. This point is 0 comma 1. And this point is 0 comma 0. Now we are integrating with respect to y. So we are moving from bottom to top. So that means bottom to top. If we look at the bottom points, so bottom points for the y value, it is changing as the value of x is changing. So along this line y is equals to x, what is the value of y? Y, it is nothing but x. So this is y is equals to x here. And for the topmost point, the points are lying along the line y is equals to 1. So this is y is equals to 1. Now what is the function f of xy? F of xy, this is 8xy. So this is equals to 8xy, and now integrate this function with respect to y. So this is equals to, and where x is in between, the x values, it is lying in between. The leftmost value, it is at x is equals to 0, and the rightmost value, it is x is equals to 1. So x is lying in between 0 to 1. So now integrate this function with respect to y. So if we are integrating with respect to y, always treat this variable x as a constant. So this becomes 8x y square by 2, because 8x are constants, and y, the integration of y with respect to y, this is y square by 2, and substitute the limits x to 1. So this is equals to 8x, when we plug in y is equals to 1, so this becomes 8x by 2, minus when we plug in x is equals to y is equals to x, so this becomes 8x cube by 2, where x is in between 0 to 1. So this becomes, this is minus 4x cube plus 4x. So this is the answer whenever x is in between 0 to 1. So the marginal density of x, that is fx of x, this is given by minus 4x cube plus 4x whenever x is in between 0 to 1, and this is 0 otherwise. So this is the marginal density of x. Similarly, now we have to find out the marginal density of y. So for the marginal density of y, that is fy at y, this is nothing but, because we are finding out the marginal density of y, so this time we are integrating with respect to x. So this is x, and the probability function, this is fxy, and we are integrating with respect to x. Again, I am sketching the region of integration. This is y is equals to 1 line, x is equals to 0, and this is y, x is equals to y. So this is x is equals to y is equals to 1 line, and this is x is equals to 0. Now, when we are integrating with respect to x, so always move from left to right. So left to right, so if you look at the leftmost point, they are lying along the line x is equals to 0. So the value of x along this line, it is nothing but 0. So the lower limit of x, it is 0, and upper limit, the rightmost point, it is lying along the line x is equals to y. So that means the value of x changes with the values of y. As y varies, x also varies. So that means x is equals to y along this line. So this becomes x is equals to y. So the upper limit of x is y. So here we are substituting x is equals to y, and the lower limit is 0. Now what is the function? The function is 8xy. So substitute the function value 8xy, and now integrate with respect to x. And here y is ranging from, varies from where to where. The lower value of y, that is this bottommost point of y it is 0, so y it is 0, and the uppermost point it is 1, so y it is varying in between 0 to 1. So this is x is going from 0 to y, so this is 0 to y, and 8xy dx. Now integrate with respect to x, so this becomes 8 and y are constants because we are integrating with respect to x. So this is 8y as it is, and integration of x with respect to x, it is x square by 2. The limits is 0 to y. So this is equals to 8y cube. When we substitute x is equals to y, so this becomes 8y cube by 2, minus when we substitute x is equals to 0, so this becomes 0. So this is 8y cube, which is equals to 4y cube. So that means fy at y, this is equals to 4y cube whenever y is in between 0 to 1 and this is 0 otherwise. So this is the marginal density of y. Now coming to the next part, that is find the conditional distribution. So conditional distribution, basically it is not mentioned that conditional distribution of x with respect to given y or conditional distribution of y given x. So we'll find out the conditional distribution for both the cases. Now for the conditional distribution, it is given by f, and if we are finding out conditional distribution of x given y, so conditional distribution of x given y, this is nothing but f of x comma y, that is the joint function of x and y, divided by what is given, y is given, so this is simply f of y. So fy, it is nothing but the marginal density of y. So this is equals to, what is f of xy? F of xy, this is 8xy. So this is, write it, 8xy divided by the marginal density of y. Marginal density of y we have calculated, that is 4y cube. It is in 0 whenever y is in between 0 to 1. So substitute the value, that is 4y cube. Now this y, this is cancels out, this is 2. So this becomes 2x divided by y square, where what is the condition? Condition is 0 is less than x is less than y is less than 1. So this is the conditional distribution of x given y. Now similarly we can find out conditional distribution of y given x. So conditional distribution of y given x, this is f of x comma y divided by f. Now this time x is given, so this is marginal density of x. So joint divided by marginal, the joint is 8xy divided by the marginal density of x. The marginal density of x, this is equals to this one. So this is minus 4x cube plus 4x. So this is minus 4x cube plus 4x. So we can take this 4x common. So this is 8xy divided by 4x common. This becomes 1 minus, and this is x square. So this cancels out and we are getting 2y divided by 1 minus x square whenever this condition satisfies. So this is the conditional distribution of y given x. This is the conditional distribution of x given y. So these are the conditional distribution. Next we have the fourth part, are x and y independent? So the condition for independence. For condition for independence, we have that if joint, that is fxy, is equals to product of marginal, then we say that the two random variables are independent. So now the joint distribution is nothing but 8xy. So here fxy, that is, this is 8xy, this is equals to 8xy. Now what is fx of x? So fx of x, this is equals to, fx of x, this is equals to minus 4x cube plus 4x. So this is minus 4x cube plus 4x, and fy at y, this is equals to 4y cube. So this is 4y cube. So when we multiply these two marginal densities, that is fx of x multiplied by fy at y, this is equals to minus 4x cube plus 4x, and this multiplied by 4y cube, which is not equals to the joint function, and hence x and y are not independent. So this is the fourth case. Okay, so since we skipped the first part, that is the first part is probability x is less than half intersection y is less than 1 by 4. So coming to this part, so now we have to find out probability x is less than half intersection y is less than 1 by 4. So first we sketch the actual domain where the function is defined. So the actual is 0 is less than x is less than y. So first we sketch this actual, that is 0 is less than x is less than y is less than 1. In this region the function is well defined. Then we'll find out the common region according to this problem. So this is, if we are plotting the function, that means this is something like this. This is y-axis, this is our x-axis. So for this, x is equals to 0, x is equals to 0 is this line. So this is x is equals to 0 line. Then we have x is equals to y, x is equals to y, it is this line. And then y is equals to 1, so this is y is equals to 1 line. So this is y is equals to 1, this is x is equals to y, this is x is equals to 0. The points are 1, 1, this is 0, comma 1 and this is 0, comma 0. Now we'll find out this region where we have to find out the probability, that is x is less than half. So first x is less than half. So if this point is, that means this line, it is for x is equals to 1, x is equals to half, it is somewhere here, that is x is equals to half. So that is this line which is parallel to y-axis. And what is this point? This point is 1 by 2, comma 1 by 2. And then y, so corresponding to this point on the y scale, this is 0, comma 1 by 2, because y is 1 by 2 here. Now, so that means x is equals to less than half, it is less than this one. So this is basically this entire, x is less than half, it is this one, this entire one. Okay, now we have to find out this area. This is for x is less than half. Intersection y is less than 1 by 4. So y is less than 1 by 4. We'll look at this region. So if it is y is equals to 1 by 2 line, so y is 1 by 4, that is it is this one. So this point is 0, comma 1 by 4. So that means this line which is parallel to x-axis, this is for y is equals to 1 by 4. So that means y is less than 1 by 4, it is in this area. The area is basically this one. So I'm sketching the region, that is y is less than 1 by 4, it is this region. This is y is less than 1 by 4. Common area, that is for this 0 is less than x is less than this. So that means this is the entire region for this one. And x is less than half. So basically the common area, it is this one only. So this is our common area, that is the line where we have to find the probability. It is for y is equals to 1 by 4 line. This is for x is equals to y line, and this is x is equals to 0. So this region, it is the common region within this defined domain where the function is well defined. So that means in this region we have to find out the probability. So now we'll find out the probability. So this is probability x is less than 1 by 2 intersection y is less than 1 by 4, and the region for this is x is equals to 0, this is x is equals to y, and this is y is equals to 1 by 4 line. So I'm writing this name, that is this, and this is x is equals to 0. So this time we have to integrate the function within this region. So that now this is integration. First I'm integrating with respect to y, then with respect to x. You can integrate with respect to x first and then with respect to y. So here the order of integration is dy dx. What is the function here? The function here is 8xy. So 8xy. Now what are the limits for y? So we know that for y limits will move from bottom to top, and for x limit we move from the left to right. The outer limits are always the constant limits. So x, it is varying from where to where. X, it is varying from, that is x is equals to 0 and x is equals to 1 by 4. So x, it is varying from 0 to 1 by 4. So the x values is 0 to 1 by 4, and when x is varying from 0 to 1 by 4, how y is varying? So for y points we are moving from bottom to top, so y is varying from bottom to top in this way. So the lower limit of y limits, it is changing with the values of x as x is varying. So the lower limit, it is changing with the values of x. So along this line, because the lower points, bottom points, it is lying along this line, so the y value along this line, it is equals to x, and the topmost point along this line, so the values of y along this line, it is 1 by 4. Now integrate the function. So this is equals to x is going from 0 to 1 by 4. Now integrate this function with respect to y first. So this becomes 8x y square by 2, and then the limits is x to 1 by 4, and then with respect to x, so this is equals to 0 to 1 by 4. Substitute the y as 1 by 4 first, so this becomes 8x by 32 minus, when we substitute y is equals to x, so this becomes 8x cube by 2. Now integrate with respect to x. So first we will solve this. So this becomes 1 by 4, and this is simply 4. So first integrate with respect to x, that is x by 4. So this becomes x square by, is it, yeah, this is x square by 8, and minus, then x cube, integration of 4x cube, so this becomes 4x 4 by 4, and the limits from 0 to 1 by 4, so this becomes 1 by 8, that is 16 into 8, this is 128, minus this cancels out, this is 1 by 256. So this is equals to, if we take the LCM as 256, so this is 2 minus 1, which is equals to 1 by 256. It is the probability. Now coming to the next question, that is the joint density for xy. It is given as fxy, which is equals to this one. So this is 15x square y, where x is greater than 0, x is less than y, and y is less than 1. So this is the domain where this function is well defined. So find expected value of xy, x, and expected value of y. So now if you know the formula for expected value of xy, by definition, this is equals to, since here both x and y are the continuous random variable, it is a case of a two-dimensional continuous random variable. So instead of summation, we're going to use integration. For the continuous, we'll use integration. So integration over x values, y values. So here I'm taking the order of integration as dy dx. You can take the order of integration as dx dy. So first integrate with respect to x and then y. So accordingly the limits will be changed, and it is the function, whatever be the function, so write this as it is. So this is xy and their joint function, that is f of xy. So this is for the expected value of xy. Then we have expected value of x. This is, since here we are finding out for a univariate, that is only a single random variable x, so that means we are going to integrate with respect to x, and this, what is written here, x here, so the function is x only, and take the marginal density of x and integrate with respect to x. So here instead of taking the joint, we are simply taking the marginal density of x, and similarly expected value of y. So this is integral over the y values, integrate with respect to y. What is the function here, y, so write y as it is, and this is marginal density of y. So these are the formulas for expected value of x, y, x, and y. So we'll calculate one by one. So first we compute the marginal densities of x and y. So the very first step is to sketch the region where the function is defined. So first we'll sketch this region, that is 0 is less than x is less than y is less than 1. So the region is 0 is less than x is less than y is less than 1, and the region is, here we have y-axis, this is x-axis, x is equals to 0 is this line, y is equals to 1 is this line, and x is equals to y is this line. So this is x is equals to y line, this is y is equals to 1, and this is x is equals to 0. Corner points are, this is 1 1, this is 0 0, and this is 0 1. So this is the first step. Now to compute the marginal density of x, so fx of x, whenever we are computing the marginal densities of x, integrate with respect to the y values. So here y values, that is, will take the limits for y y, integrate with respect to y, and whatever be the joint function. So the joint function here is 15x square y. So this is 15x square y. So what are the y limits? Whenever we have to integrate with respect to y, simply move from bottom to top. So bottom to top here, if you look at this, the bottom points, it is lying along which line? What is the value of y on this line, that is the bottom points, it is lying along the line y is equals to x. So the value of y, it is equals to x. And the topmost point, it is lying along which line? It is lying along the line y is equals to 1. So the limits for y, it is from x to 1, because along this y is equals to 1 line, whenever x is varying from 0 to 1, y is varying from x to 1. So these are the limits for y. And what are the limits of this x? So x is varying from 0 to 1. So this is equals to, simply integrate this with respect to y. So this becomes 15x square y square by 2, and the limits are x to 1. So substitute y is equals to x here. So this is coming out to be where x is in between 0 to 1. So this becomes 15 by 2 x square as it is, and y, when we substitute y as 1, so this is simply this one, and this is 15x to the power 4 by 2. So this is the marginal density of x whenever x is in between 0 to 1. So from here we can compute the expected value of x as well. So expected value of x, this is integral over x limit. Now this is the marginal density, that is fx of x, and x is from 0 to 1. So we'll take x limit. So x is moving from 0 to 1, and the function is x here. The marginal density fx of x, this is given by 15 by 2 x square minus 15x4 by 2, and integrate with respect to x. Okay, so this is the expected value, and in this way we can compute the expected value. So we'll compute the expected value here, that is expected value of x, where x is moving from 0 to 1, and the function x with the marginal density of x, this is 15 by 2 x square minus 15 by 2 x to the power 4. So this is 15 by 2 x square minus 15 by 2 x to the power 4. Integrate with respect to x, we can take 15 by 2 outside of this integral, and this becomes x cube minus x to the power 5. Integrate with respect to x, the limits from 0 to 1. So this is 15 by 2, and when we integrate with respect to x, so this is x to the power 4 by 4 minus x to the power 6 by 6, limits from 0 to 1. So this is 15 by 2, and it is 1 by 4 minus 1 by 6. So this is equals to 15 by 2, and this 6 minus 4 by 24, which is equals to 15 by 24. So this is the expected value of x. Now for expected value of y, we first have to calculate the marginal density of y. So that is fy at y. This is nothing but, because we are finding out the marginal density of y, so we'll integrate over x values, whatever be the function. The function is 15x square y. So write it 15x square y, and integrate with respect to x. So again I'm sketching the region. So the region where the function is defined, it is this one. So this is x is equals to y line, this is y is equals to 1, and this is x is equals to 0. So since we are integrating with respect to x here, so we have to move from left to right. So this is left to right point. So the leftmost point of x, it is lying along the line x is equals to 0. So the lower limit of x, it is equals to 0, and the upper limit, that is the rightmost point of x, it is lying along which line? It is lying along x is equals to y. So the value of x, it is equals to y here, and the function is 15x square y. Integrate with respect to x, so this becomes 15x cube y by 3, and the limits from 0 to y. Substitute x as y, so this becomes 15 by 3, this is simply 5. So this comes out to be 15y4, that is, and what is y? y it is varying from where to where. That means this y it is varying from 0 to 1. So fy of y, this is 5 by 4 whenever y is in between 0 to 1. Now expected value of y, this is nothing but integral. We have to integrate with respect to y. What is the function here? Function is y. Marginal density of y, it is 5 by 4. And integrate with respect to y. So the values of y, it is 0 to 1. So now integrate with respect to y. So this becomes 5y5 and integrate 0 to 1 dy. So this is equals to 5y6 by 6. Limits are 0 to 1. So this is simply 5 by 6. So this is the expected value of y. Now coming to the expected value of xy. So for expected value of xy, this is equals to limits for x, limits for y. Here the function is xy. So write this xy as it is. It is a function of two random variable. It is again a random variable. So take the joint function of this xy. So this is fxy. If we are integrating with respect to y first and then with respect to x, so take the y limits here and this is the x limit. So I'm again sketching the region where the function is defined. So this is y is equals to 1, this is y is equals to x, and this is x is equals to 0. So if we are integrating with respect to y first, so for y we need to move from bottom to top. So bottom to top. So this in this the bottom points it is lying along the line y is equals to x. So the lower limit for y is equals to x, and the upper limit, the topmost point, they are lying along the line y is equals to 1. So this is y is equals to 1, and x values it is varying in between 0 to 1 because this point is 1 1. So x values it is varying from 0 to 1. X is equals to 0 and x is equals to 1 here. So this is equals to 0 to 1. This is x to 1, that is y is equals to this xy, and the function is 15x square y dy dx. So this is 0 to 1. Then integrate with respect to y first. So this is simply 15x cube. That is this x square and x square and x. This is x cube and y into y. It is y square. So integration of y square with respect to y. This is y cube by 3, and then take the limits x to 1 and then integrate with respect to x. So this is coming out to be 5x cube y cube. Substitute y is equals to 1 and then y is equals to x. So this is equals to 0 to 1 5x cube and then minus 5x6 and then integrate with respect to x. So this is equals to 0 to 1 5. We can take this 5 outside of this integral, and integration of this one, integrate directly, that is x cube integration is x4 by 4 minus x6 integration is x7 by 7. Take the limits as 0 to 1. So this is equals to 5, that is 1 by 4 minus 1 by 7, and finally this is 7 minus 4, that is this is 28. So this is 15 by 28. So this 15 by 28, this is the expected value of xy. Now the next question is the joint density for xy. It is given as fxy, which is equals to 60x square y, where the domain, where the function is defined, it is xy, it is in between 0 to 1, and x plus y is less than equals to 1, and this is 0 otherwise. Find the conditional distribution of x given y. So conditional distribution means, that means x given y. So x given y, we can write this as this one. So conditional distribution, it is equals to joint divided by marginal. So joint is f of xy and marginal is what is given, y is given. So that is the marginal density of y, fy at y, provided fy at y is not equals to 0. Okay, so this is the conditional distribution of x given y. So for this joint is given to us, that is f of x comma y, it is given to us. We have to find out the marginal density of y only. Okay, so the first step is to sketch the region where the function is defined. So first we'll sketch the region. Region is, that is 0 is less than equals to xy, is less than equals to 1, that means both xy it is lying in between 0 to 1, and the second condition is x plus y is less than equals to 1. So this is our y-axis, this is the x-axis. X is equals to 0 line, that means this is x is equals to 0 line, then x is equals to 1, let this is 1, so this is x is equals to 1, y is equals to 0 line is this one, and y is equals to 1. So this is x is equals to 0, x is equals to 1, y is equals to 1, and y is equals to 0. One more condition is given, that is x plus y is less than equals to 1. So first sketch the line x plus y is equals to 1. So when x plus y is equals to 1, when x is 0, y is 1. So when x is 0, y is 1, this is the point. When y is 0, x is 1, that is this is the point. So this is the line for x plus y is equals to 1. That is x plus y is equals to 1. Now we have to find out the common region for this. Either we have this region or this region. That is, this is the first or the second. So we have to find out which one is the region. Simply pick a point from any of the two regions. Let if I'm taking the point from this region. So the point is, this is point 1 comma 1, and substitute in this condition whether it is fulfilling this condition or not. So if x is equals to 1, y is equals to 1, so we have 1 plus 1 is less than equals to 1, 2 is less than equals to 1. So that means this is not the condition, that means it is not fulfilling the condition. So this is not the region is this one. This is the region where the function is well defined. Now I'm plotting this region again. That means this is x is equals to 0 line, y is equals to 0, and this is x plus y is equals to 1. And the corner points are, this is 0 0, this point is 1 0, and this point is 0 1. So we have to integrate in this. So first, in order to find out the conditional distribution, that is, first we have to compute Fy at y, that is the marginal density of y. So in order to compute the marginal density of y, we have to integrate over x values, and we know that for x values we move from left to right. So that means left to right for this region. If you look at this one, the leftmost point, it is lying along which line? It is lying along x is equals to 0. So that means at all the leftmost points, this is lying along x is equals to 0. So the lower limit is x is equals to 0. And the rightmost point, it is lying along the line x plus y is equals to 1. So that means the x values along this line, it is nothing but 1 minus y. And the function it is given as 60x square y. So simply write the function as 60x square y and integrate, because here we are finding out the marginal density of y, so integrate with respect to x. And the y, it is varying from where to where? Y, it is varying from 0 to 1. So 0 is less than equals to y is less than equals to 1. So now this is equals to, when we integrate with respect to x, so this becomes 60 x cube y by 3, and the limits from 0 to 1 minus y, which is equals to 60, substitute x is equals to 1 minus y, so 60 y by 3 as it is, and this becomes 1 minus y cube. When we substitute x is equals to 0, this is 0, so this is coming out to be 20y 1 minus y cube, and y is in between 0 to 1. So this is the marginal density of y. Now conditional distribution of x given y, so this is x given y, this is nothing but conditional joint divided by the marginal density of y. So the joint function, this is 60x square y, so this is 60x square y, and the marginal density it is 20y, that is 20y divided by 1 minus y cube. So this cancels out. So this is 3. This y cancels out. So finally it is equals to 3x squared divided by 1 minus y cube. Provided the conditions, whatever the conditions are given, that is 0 is less than equals to x is less than 0 and y is less than 1, and x plus y is less than equals to 1. So these are the condition, and this is the conditional distribution. Now one more question. The question is, let the joint PDF of x and y be this one, that is fxy, it is k into x plus y where x is greater than 0, y is greater than 0, and 3x plus y is less than 3, and this is 0 otherwise. Find the value of this constant k. Now the first step is to sketch the region where the function is defined. So if this is y-axis, this is x-axis. X is greater than 0, that means first we have to sketch the line for x is equals to 0. So x is equals to 0, it is the line, this one. This is the x is equals to 0 line. Then y is equals to 0, this is y is equals to 0. So x is greater than 0, that means this portion to the right of this line, y is greater than 0 to the above of this line. Okay, now 3x plus y is less than 3. So first we have to sketch the line for 3x plus y is equals to 3. So when x is equals to 0, the value of y is equals to 3. If we substitute x is equals to 0 here, y is equals to 3. So this is 1, 2, 3. So x is equals to 0, y is equals to 3 here. And when we substitute y is equals to 0, x is equals to 3. So when we substitute y is equals to 0, x is equals to 1, not 3. So this is x is equals to 1. So the point is this one. So that means join these 2 points, and this is the equation of the line 3x plus y is equals to 3. Now what is the region 3x plus y is less than 3? So this is the region, that means less than 3 is this one. Simply pick a point here for this region 0, 0. If we substitute the value x is 0, y is 0, 0 is less than 3. Yes, this lies in this region only. So this is the region. So this is x is equals to 0 and this is y is equals to 0. So that means the region where we have to, where the function is defined, this is this region. So I am simply plotting this region, that is this is x is equals to 0, y is equals to 0, and this line is this for 3x plus y is equals to 3. So this point is nothing but this is x is equals to 1, y is 0, and this is x is 0, y is 3. So in this region we have to, the function is defined. Now find the value of k. So for this, that means here we have the region is something like this. Okay, this is 1 0 0 0 and this is 0 3. This is 3x plus y is equals to 3, x is equals to 0, and this is y is equals to 0. So for this, we have two ways. Either we take the order of integration as dy dx or dx dy. So because this is a joint probability density function, and we know that for a joint probability density function, integral over x values, integral over y values, this f of xy, either you take it as dx dy or dy dx, this must be equals to 1 if it is a joint probability density function. So that means we have to integrate over x or y, and then this must be equals to 1. So this is, this time we are taking first with respect to x, because in all the previous three questions first we integrate with respect to y, then with respect to x. So here first we are integrating with respect to x and then with respect to y. Okay, so this is x with respect to y, and the function is k into x plus y. So this is k into x plus y. Now we have to take the limits. So outer limits are always constant. So that means y limits, this is constant. So y values, it is lying in between which to which. Y is equals to 0 to y is equals to 3. So y values, it is lying from y is equals to 0 to y is equals to 3. So this is y is equals to 0 to 3 because these are the outer limits. So when y is varying from 0 to 3, how x is varying? So for x values, we have to move from left to right. So now just look, the leftmost points, these are lying along which line? It is lying along the line x is equals to 0. So this is x is equals to 0, and the rightmost point, it is lying along the line 3x plus y is equals to 3. So from here the value of x is equals to 3 minus y by 3. So in this way we can integrate this function. Now we have substitute this is equals to 1 and find the value of k. Now we'll integrate this function first with respect to x and then with respect to y. So take the y limits as it is, that is y is going from 0 to 3. We'll integrate here, k is a constant, we'll take it outside this integral, that is k. Integration of x with respect to x, so this is x square by 2 plus integration of y with respect to x, this becomes xy, and the limits of x is 0 to 3 minus y by 3, and then integrate with respect to y, and this is equals to 1. So this k as it is. Now substitute x is equals to 3 minus y by 3, so this becomes 3 minus y whole square divided by 3 square. 3 square is 9 and 9 multiplied by 2 is 18. So this is 18 plus, then substitute x is equals to 3 minus y by 3. So this is 3 minus y by 3 and this multiplied by y. When we substitute x is equals to 0 in both the terms, it is equals to 0, and then integrate with respect to y, and this is equals to 1. So this k as it is. Now here we are integrating these terms with respect to y. Okay, 0 to 3. So this is 0 to 3, 3 by 18. So this is coming out to be 9 by 18. Then we have y square by 18. Then minus, this is 6y by 18. Then plus, this is simply y, minus, this is minus y square by 3. Integrate with respect to y, and this is equals to 1. So this is 1 by 2. This is 1 by 3. So now we'll integrate this function. So I'm writing this function again, that is k from 0 to 1, and this is 1 by 2 plus y square by 18. So this is 1 by 2 plus y square by 18. Then this is minus y by 3 plus y, minus y by 3 plus y. Then this is minus y square by 3. This is minus y square by 3. The limits from 0 to 3. So this is the limits from 0 to 3. Integrate with respect to y, and this is equals to 1. So this k as it is. Now the integration of 1 by 2 with respect to y, this is y by 2. Integration of y square by 18 with respect to y, this is y cube by 54, minus integration of y by 3, it is y square by 6, plus this is y square by 2, minus this is y cube by 9, and the limits are 0 to 3, and this is equals to 1. So this is k into, substitute y is equals to 3, so this is 3 by 2, plus this is 27 by 54 minus 9 by 6 plus 9 by 2 minus 27 by 9, and when we substitute y is equals to 0, this is 0 only, so it is equals to 1. Now this is equals to k as it is. Take the LCM. First cut, this is 1 by 2, this is 3 by 2, and this is 3 only. Take the LCM. So here the LCM is 2. So this becomes 3 plus 1 minus 3 plus 9 minus 6. And this is equals to 1. So this 3 cancels out. So this becomes 10 minus 6. So 10 minus 6 is 4. So this is 4 by 2 is equals to 1. And this implies this is 2. So from here k is equals to 1 by 2. Now this is a question for practice, the same question that we discussed just now. So the question is same, but in this you have to find the value of k by taking the order as dy dx. The question that we just did, in this we take the order as dx dy. This time you have to take the order as dy dx. Then find the marginal densities of x and y. Check whether x and y are independent or not. Then find expected value of x, y, and expected value of xy. Find covariance between x and y, and then find conditional distribution of y given x. That is conditional distribution of y given x. So please do this question and let me know your answers in the comment box. If you have any queries, you can mail me your queries at my mail ID. The mail you can find it in the description box. I'll share it there. And if you like this video, please hit like and subscribe to my channel. Thanks for watching.